Good morning, students. A warm welcome to you all, children. Today, we are going to discuss lesson 4 in chemistry, that is, structure of the atom. Here, you can see two pictures, children, that is related to atom. The first one is the atom is made up of the three subatomic particles, and this is the shell where you can see the subatomic particles are protons. Then the outer particle, that is electrons, which is indicated by E, proton indicated by P, and neutron is in the center of the atom, which is neither positive nor negative, that is at the nucleus. So nucleus is consisting of protons and neutrons. So there are mainly three subatomic particles in the atom, that is electrons, which are negative, protons, which are positive, and neutrons, which are neutral, that is neither positive nor negative. In the second structure, you can see very clearly, children. So the middle part of the atom is nothing but the nucleus. And here you can see the protons, the blue color one, which is protons. This one, this is neutrons, and the electrons are revolving around the nucleus. Okay, children? Right. Now, what are atoms? The atoms and molecules are the fundamental particles, building blocks of matter. The atoms and molecules are the fundamental building blocks of matter, like the cells. We know that a cell is a basic structural and functional unit of life. So in the same way, how the cell forms the tissues forms organs, which forms the organ system, and finally the organism. In the same way, the atoms are the smallest particles, which is equal to a cell, and the group of atoms forms the molecules. So these atoms and molecules are the fundamental building blocks of matter. The existence of different kinds of matter is due to different atoms constituting them. The existence of different kinds. We know that matter exists in three states, that is solids, liquids, and gases. So the existence of different kinds of matter is due to different atoms. So it is because of the atoms present in them. So now we are going to learn about the charged particles in matter. So regarding this, in the year 1900, the scientist known as J.J Thomson identified one subatomic particle, that is electron. So J.J Thomson in the year 1900 identified one subatomic particle that is present in the atom, and that subatomic particle he named it as electron. So before J.J Thomson in 1900, there is one more scientist called as Goldstein in the year 1886. He discovered the presence of new radiations in a gas discharge and called them as canal rays. So he did experiment using a discharge tube that where canal rays are produced, and he identified the another subatomic particle which is present in the atom, that is nothing but called as protons. And this protons is equal in magnitude but opposite in sign. Means here electron is negative and the protons are positive. That is why we say that they are equal in magnitude but opposite in the sign. The mass of proton is 2000 times as that of electrons. The mass of proton, mass is nothing but the quantity of matter, right? So the proton's mass is 2000 times more than the mass of the electrons. Means in the atom, most of the part is completely filled with the protons, that is positive charge. Okay, children? And its mass is 1 unit. The mass of proton is 1 unit and the charge is +1. Okay. The mass of electron is negligible as most of the mass of proton is occupied by the protons. The mass of the atom is occupied mostly by the protons. So the mass of electron is negligible and the charge is -1. So the electrons are negatively charged whose charge is -1 and their mass is negligible when compared to that of the protons. And the proton's mass is 2000 times more than that of electrons and its mass is 1 unit and charge is +1. So we came to know that the atom consisting of the particles, that is electrons, charged particles called as electrons, which was discovered by J.J. Thomson in 1900, and protons, which was discovered by the Goldstein in the year 1886. Okay, children. And in the middle, we have the nucleus. Okay, so nucleus consists of the protons and the neutrons. So neutrons means they have neutral charge. They do not have a charge. They are neither positive nor negative. And protons are positive charge. Okay, right. Now we are going to learn about the Dalton's atomic theory. So Dalton is a scientist. Here you can see the picture, children. So he is John Dalton and he was the first person to give the atomic model of an atom. Okay, atomic model. So that atomic model is nothing but called as Dalton's atomic model. So according to Dalton's atomic model, John Dalton in the year 1808, John Dalton presented his theory and that theory is called as Dalton's atomic theory and this is his model. Okay, so which states that all matter is made of very tiny particles called atoms. So John Dalton said that all the matter is made up of very tiny particles called as atoms and these particles are indivisible, means they cannot be divided further. Okay, very small particles they are and which cannot be created or destroyed in a chemical reaction. So when any chemical reaction is taking place, the atom is a very smallest particle. So you call it as indivisible particle which cannot be neither be created nor be destroyed in a chemical reaction. Okay, and the discovery of the two fundamental particles which was discovered by Goldstein, right? So Goldstein and Thompson, it led to the failure of his Dalton's atomic theory because he told that the atom is a very smallest particle and it is indivisible particle and cannot be created or destroyed, but he could not explain it. So the discovery of the two fundamental particles, that is the protons and electrons, led to the failure of his theory. Okay, children, so he is John Dalton and this is his atomic model. After John Dalton came the Thompson. So here you can see the picture, that is Thompson model of an atom. So Thompson, he has proposed the model of an atom which is similar to the Christmas pudding. Okay, so this is the Thompson's plum pudding model of an atom where you can see the electrons in a sphere of positive charge. So this complete what you can see, the skin color, the pink color one, this is a positive charge and the electrons are present in the positive charge. Okay, and even we can think like the Thompson plum pudding model is similar to the watermelon. So where in a watermelon we can see the red color sphere. When you cut the watermelon, you can see the red color sphere. So that red color sphere is nothing but the positive charge and the seeds, the black seeds which are embedded in the watermelon, that is in the positive sphere inside the red matter, that is considered as a electron. Okay, so here we can think the Thompson's plum pudding model similar to that of the watermelon. So here the positive charge in the atom is spread all over. In a watermelon, the positive charge of the atom is spread all over, completely it is spread, and that is the red edible part, while the electrons are studded in the positively charged sphere like seeds. Okay, so positively charged sphere, the electrons are present in the positively charged sphere like the seeds. So this is his plum pudding model. In plum pudding model, this is a Christmas like a plum, the cake, and here they use the what you call it as the dry fruits, which are present in the plums, the plum cakes and all. Okay, so that is similar to that of the electron. So here this is a ball of positive charge, and here the blue color ones, what you can see, they are all electrons. Okay, so according to the Thomson model of an atom consists of positively charged sphere. So it consists of a positively charged sphere, and the electrons are embedded in it, they are present in it. The negative and positive charges, and the negative charges are equal in magnitude. Okay, so he said that the negative charges and the positive charges which are present, they are equal in magnitude. So when they are equal in magnitude, the atom is considered as electrically neutral. So the atom as a whole is electrically